Hello everyone. Yes, today we are going to talk about the Suez Canal. The Suez Canal blockage has been in the news recently, and we are going to talk about the technical aspects of the same, why the Suez Canal got blocked, how the Suez Canal got blocked, and how it was finally freed. We are going to talk all about that. First, let us talk about the Suez Canal in brief. Suez Canal is one of the busiest, most routes when it comes to cargo or ships. It handles about 12% of global trade, and as we know that crude oil, one of the major fuels of the industry, is being transferred generally through cargo using ships. So the crude oil prices went high up in recent times due to this blockage of the Suez Canal. Basically, when the Suez Canal gets blocked, you will have to follow an alternative route, which is below South Africa in the map, if you see, through the Cape of Good Hope. And if we take that route, it will take about 2 weeks longer to transfer the goods. So that is the amount of loss that you will incur in terms of time and money if you follow the alternative route. Whereas the Suez Canal is definitely, as I said, 12% of global trade it handles. So it is one of the busiest routes in world trade, and that's why it is of so significant interest, because it provides an easy trade route, the shortest trade route with the lowest amount of time in between Europe and Asia. And that's why the blocking of the Suez Canal created a lot of chaos in world trade market particular. In fact, in some of the places, it was also heard that the toilet papers will fall short, and the crude oil prices went shooting high up. And recently, it has been freed up about 6 days after its blocking. So, how did it get blocked? Let us talk about that, because it's a very interesting case of engineering science. If you have studied class 11 12 science, you will also be able to figure out this, because you have heard about Archimedes' principle, how the ships float on water. The cargo with so much of load. In fact, if we talk particularly about this particular ship that got stuck in the Suez Canal, it's named Ever Given, and it's under the company of Evergreen, which is a Japanese company. The ship is being manufactured by Japan, handled by Taiwan, and the crew members were Indians. So it is a diversified ship, and the ship basically got stuck diagonally, because the Suez Canal is about 300 meters in width and the ship is about 400 meters in length. So the ship got stuck diagonally, blocking the entire canal, thus prohibiting the passage of any further ships to and fro Europe to Asia. And as we were talking that Archimedes' principle, if we talk about this particular ship, it weighed about 2 lakh tons. 2 lakh tons, yes, that's the amount of load it had on itself. And the counterbalancing weight is just by the amount of volume of water it displaces in the Suez Canal. The water, by the virtue of buoyancy, is trying to keep the ship up. We know that the amount of force the water exerts on a particular object is the weight of the water displaced by that particular object. Supposedly, I keep a ball, the amount of water displaced by the ball, the same amount of water, the weight of the same amount of water is going to be exerted as a buoyant force on the ball itself. And this was basically the Archimedes' principle, and that tries to keep the ball floating, and the weight is counterbalanced by that amount of force. If the buoyant force is greater than the weight of the object will float. If the object's weight is greater than the buoyant force on complete displacement of the liquid, the object will sink. And this is the principle of Archimedes' principle, Archimedes' law. And what happened in Suez Canal was basically a typical engineering problem. A lot of a sudden gust of sandstorm hailstorm came in, and the boat got turned. So it was traveling like this, and it got turned. And the minute it got turned, it stuck in between the canal. And the satellite images are also available on the internet. You can search over it, and it blocked the entire canal, because it was 400 meters in length, and that's the maximum permissible limit of the length of a ship in Suez Canal. And the moment it was stuck, it prevented the further flow of ships, and they got piled up. About 400 ships were waiting for the Ever Given ship to free up. Now what happened is, as it turned, it got stuck in the silt. or the clay that was surrounding the Suez Canal, or basically at the periphery of the Suez Canal, if we say, it got stuck in the silt and the clay. And the minute it got stuck in the silt and the clay, the water, due to the low tide, was also less at that point of time, and it basically provided an environment where the ship got stuck in the land rather than floating on water. So we needed plenty of water to let the ship float on it, and we needed to remove the piece of land, and that was exactly what the Egyptian government tried to do. Basically, the Egypt government straight away took the excavators to the side, the diggers. They tried to dig away the land. They even resorted to sending ships that sent in a boom into the water and tried to dig out the clay or the sand, so that the ever given ship can get sufficient amount of water again to float on, and it doesn't get stuck to the land. So it was basically removal of land to allow the passage of water, so that the ship can further float, and hence the ship can be turned. But eventually the digging was not enough, and 13 tuggers, yes, 13 tugs, basically strong small ships, were sent in, which were tied or knotted to the main ever given ship, and they were providing a tortuous flow, providing a torque to turn around the ship back to its normal course length. And basically 13 ships were sent for that purpose. So constant digging by excavation, constant digging by submersible booms to excavate out the land to provide water, and tugs, 13 tugs, trying to balance off and trying to pull back the ship to its natural course walk. And it took a sufficient amount of time, 6 days, but finally the ship has been recently freed, and the Suez Canal has been freed, and that's why the global trade is back to norms and the crude oil prices are back to normal. But what engineering method was applied was excavating the land so that the ship gets exposed to further water, so that it can float under Archimedes' principle. And the second was tug fitted, and definitely mechanically balanced forces were applied to apply the maximum torque so that it gets again vertical or takes its normal course length. Apart from that, submersible booms were sent underwater to dig the land to further allow the passage of water. And a natural phenomenon was being waited upon for, which finally pondered upon the scenario, and by God's grace it happened. That was high tide. The moment the ship got stuck was a low tide moment, with a lot of sandstorm and hailstorm. They were waiting for the high tide, because once the high tide comes in, the water will automatically upheave the ship in itself, and will again, by Archimedes' principle, it will float. And once the ship floats, it will come to its normal length course, and it will travel. And that's exactly what happened. The ship, the high tide helped the cause, and the tugs, 13 tugs, flotillas were sent. They did a fantastic job, and the excavators and the submarine submersible booms did a fantastic job, and altogether the ship refloated. Another principle that was planned to being implemented if these certain measures failed was the deloading of cargo. Now, what is it? How is engineering associated with it? As I've already told, that the moment the weight of the cargo, weight of the ship is higher than the buoyant force that the water is applying on the ship will tend to sink or go down, and the moment it goes down, it gets stuck to the land sideways. So what they were planning to do was, they were trying to deload the cargo or the goods that were loaded on the ship. The moment they deload the cargo, what happened is the weight of the ship decreased, and that's why the tendency to sink against the buoyant force again was going to be low, and it would have a primary tendency to float on the water. And that was the principle that was trying to be employed. If these measures would have failed, this was the thing that was in plan to be implemented. But nevertheless, by God's grace and by the efforts of the Egyptian government and the tugs in particular, the ship was finally freed, and all thanks to the people that worked on ground. And that was all about the Suez Canal blocking, because that was a lot of chaos regarding the concepts of how it got blocked and how it got freed finally. So the global trade is back to normal, the crude oil prices are down, and hopefully we will survive it all together. So that's it for today. I hope you find it interesting. We are trying to bring more diverse topics, and we will keep on continuing doing so with other industrial topics and other interesting topics, whatever comes to our mind. Thank you very much, and if you liked it, like it, subscribe to our channel, share it with your friends. That's it for today. Thank you.